How's that?
Okay.
Here is our friend acetyl salicylic acid. It starts off, we said, as salicylic acid, you add acetic acid to it, and you make acetyl salicylic acid. Salicylic acid can be isolated from willow trees or can be made artificially. You add acetic acid to it, and you get acetyl salicylic. It's actually a very easy reaction to do. We do it in a lab with our other students sometimes. Now, what I want you to do is look at that acetyl salicylic acid on the right. I see at least 3 functional groups there. Can everybody tell me what those functional groups are? Look at the aspirin. Tell me what the functional groups are.
There's 2 carbonyls and alcohol.
Well, but the carbonyls are joined with other stuff, so they're not really, they're called something else, right? Look at the top of it, the top right. What kind of group is that? What is this group up here? What did we start off the class talking about? What is this? Carboxylic acid, right? What's this group right here? It's a benzene ring, also called what? It's an aromatic, isn't it? And what's this group right here? What are we talking about? What kinds of molecules are we talking about? It's an ester. Huh?
I'm writing a highlighter to get her to tell what I'm writing. I was finding myself.
Oil of wintergreen is also an ester. It's not quite as common as it used to be. Passes through the skin. Some people use it to soothe tired muscles. Smell a lot like in locker rooms and stuff. Like it's the smell that you smell like in dengue and stuff. Okay. It's called methyl salicylate as opposed to acetyl salicylate. Look at that molecule. What are the 3 functional groups? Is there an ester there?
Yes.
Where is the ester? At the top right. What else is there? There's an aromatic, because it's got a benzene ring. And what else was there? It's a hydroxyl, so it is also an an. When you have a hydroxyl, it is an alcohol. Okay? Name them. Lots of these molecules are responsible for some of the smells that you get from fruits, like pineapples and pears and things like that. Okay? Small ones are very volatile. Small esters are volatile, means they go into the atmosphere. They form a gas very easily. Okay? They're also soluble in water, so you can taste them as well. Pears taste different than bananas, and bananas taste different than pineapples, don't they?
Yes.
Look at the difference in the molecules. How much difference is there? Look at the difference between pears and bananas. What's the difference in the molecules?
There's 2 more carbons.
There's 2 more carbons here. Right? But you know the difference in the smell of a banana and a pear, don't you?
Yes.
You know the difference in the taste?
Mm-hmm.
That's amazing.
That's a big difference for such a little change.
Don't you think that's an incredible difference? Yeah. I mean, this is like, I can see the excitement in you guys. Hold yourself back. I mean, two little things right there, 2 little carbon atoms, totally change the way pears and bananas taste.
And are formed, like, bananas are squishy and pears are kind of hard.
Yeah, that doesn't really have much to do
I mean, they
with
do
these
that.
molecules, but it has to do with the aroma that they give off and the taste of. right? Because you can't get squishy pears. Not so good, huh? But yeah, so these molecules, they're not aromatics. We said last week that a lot of aromatic compounds are things that have smells, right? These are not aromatics. None of them are. They're just they're esters that look a little bit like a carboxylic acid, but instead of having a hydroxyl, they have a carbon chain. We're not worried about this. Here's another common ester. A lot of you ladies have probably smelled before. Have you ever smelled this?
Yes.
Does fingernail polish have a unique smell to it?
Yes.
Smells different than pears and bananas do, doesn't it?
Yes.
Well, look at the difference between pears and bananas. How many? Look, I don't know if you remember. Think about this molecule right there. If it had one more carbon, it would smell like pears. That'd be cool if your fingernail polish smelled like pears, wouldn't it? Yeah, it'd be better than the way it smells now, huh?
My dad let me paint my toenails in the house instead of outside.
That's funny, he makes you go outside. No, he probably wouldn't because it'd make him hungry, yeah.
Probably. But see, I don't understand my dad because he paints cars, but he's probably found car paint. But when he smells like fingernail polish remover or fingernail polish, he's like, you gotta go somewhere.
Does he wear a respirator and paints cars?
I guess. I mean, he has the whole suit and everything.
Yeah, he probably wears a respirator so he doesn't smell that stuff very much. Because they have filters in it.
And I think there's like a high tech and it like brings oxygen into his mask and stuff like that.
Yeah, so he doesn't even smell that stuff anymore. Probably like 10 years ago when he first started painting
Yeah,
cars, or 20 years ago,
probably didn't bother him.
probably didn't bother him then. Now, yeah, probably can't stand it now.
Yeah.
Okay. What kinds of reactions do esters undergo? There's two reactions that we're going to talk about for esters. One is an acid hydrolysis. These two reactions are very similar. Let's look at what's going to happen. We are going to do what? We're going to break this molecule. Hydrogen's going to go here. OH is going to go here. This area right here where it looks like an ether, remember we said ethers are very reactive. This looks like an ether, it's extremely reactive. So what do we have? We form an alcohol, two alcohols actually. But this one, because it's next to a carbonyl carbon, is a carboxylic acid, and this one is just an alcohol, right? So acid hydrolysis, I think about it as forming two alcohols, but really it's a carboxylic acid and an alcohol. Let's look at another example of it. Here we go. We break it apart right here, and what would happen here? We would need the sodium to go here, right? Actually, they have this drawn backwards. They have it drawn where it breaks apart here. So the sodium comes here, and the OH comes here. So, had this been, right, here's our sodium attracted to the oxygen, and here is our hydroxyl group on the carbon here. So we really made, looks like right? This now is called base hydrolysis, but what has happened? We still have a hydroxyl group here, but instead of having a hydroxyl group here, we have a salt.
So is it a salt and alcohol?
We have a salt and alcohol instead of having two alcohols. Okay? So they look very similar, don't they? Acid hydrolysis really produces two alcohols. Base hydrolysis produces what? An alcohol and
Salt.
a salt. Okay? Look at the title of this. This is a base hydrolysis is also called what? Saponification. Does that word saponify sound like anything else that you might know of? It almost sounds like soap. Okay? Anybody know the show Beverly Hillbillies? In the other class, everybody's like, yeah. Okay. Let's talk about Beverly Hillbillies.
There's a movie.
Really?
And a new movie.
My mom loves that show.
Gotta watch it in black and white. That's the only way to go.
They're the black and white.
Remember Granny on it? Clampett? Old lady made moonshine? You don't know the show. Bunch of country folks that got rich on oil and they moved to Beverly Hills. But they were still country folks. So Granny, the old lady, she ran a still, right? But she also occasionally would do this. She would make soap. How did she make soap? Anybody know how she made soap?
I know you make soap, but I don't know.
How do you make soap?
Out of cow fat or any kind of fat, and you have to put some kind of toxic chemical.
Gotta put lye in it.
Yeah, not that.
Or lye is a base. Lye is like sodium hydroxide. LYE is what we call lye. So Granny would take cow fat, because you can do it with cow fat, and you can do it with any fat or oil, because they're loaded with esters. Granny would take possum fat and put lye in it and heat it up and stir it. You gotta heat it. And what happens? It breaks apart this ester molecule and it makes a salt and an alcohol. And if this tail right here has lots of carbons on it, it won't be water soluble, but it will be a salt. It will still be a salt, but this will be a soap molecule now. Okay? And this is how you make soap. You can make it out of olive oil, you can make it out of cow fat, you can make it out of pig fat, you can make it out of possum fat, you can make it out of coconut oil, any kind of oil like that, because they're loaded with esters. Okay? Yes.
When you put the lye in the product, like in the soap,
Uh-huh.
how come when lye, I guess because you put in something else that's soluble, the lye doesn't hurt you when you use the
You know, what happens is because the lye all gets used up right here. If you put too much lye in and not enough fat, you have to get the mixture just right. The lye will burn you, right? And that's why lye soap, anybody ever use lye soap? Tends to be pretty caustic because there's a little bit of extra lye in it, a little bit extra base. Okay? Because you gotta have base, right? Somebody got the joke. It's all about the base, right? Ooh. Sorry. So we could show these two reactions here. Let's think about it. Methyl acetate. Maybe we need to know what acetate is. I'll give you the starting thing here. Here's what we have. Okay? Under acid hydrolysis, what do we make? 2 alcohols, right? So we're going to get CC double bond O, OH, and then we're also going to get what? COH. Does that make sense? We're going to break, this is methyl acetate, we got to break this right here somehow. Okay? Now let's think about what would happen if we did it under basic conditions. What do we get under basic conditions? We get a salt and an alcohol. Okay? Now this is negatively charged. So we have which ion is going to be attached here? Which ion from this?
Okay.
Potassium. Why potassium?
Because
Because it's positive. Hydroxide is what?
negative.
Negative. So potassium will be attached there. And what else do we get? We get an alcohol too, don't we? So we still get, I left all the hydrogens off here because it gets messy. Okay? So do they look alike? Yeah, pretty much. The difference is that hydrogen up there, and now we have a potassium. That's it. Okay? Acid hydrolysis, base hydrolysis. Okay? Make sense? Okay.